Okay, so take 3, which you don't know, but this is take 3. Let's see if we can get this done. All righty, here we go. Multiplication algorithms. Remember that multiplication is repeated addition. I mean, that's really what we need to be thinking about in the back of our mind. First, let's take a look at a concrete model with repeated addition here. And so we've got 3 times 12. So I'm going to draw 3 groups. Here's one group. Two groups and 3 groups. So this demonstrates that we have 3 groups of 12, remembering that the long is worth 10 and the units are worth 2. So these are actually 3 groups of 12. And we can add those up. We can see that we have 3 flats, which is equal to 3 times 10, which is 30. And we have 6 units, which is 6 times 1, which is 6. And when we add these guys together, we get 36. So we'll do the same kind of idea with the concrete model. And when you do the concrete model, we're gonna draw 3 sets of 12. Okay, so I'm going to start off by drawing 1 set of 12, because notice that this is an array, and an array is different. We're dealing with an array here. So I've represented a 12. That's 1, 10, and 2 units. So that's 12, and it was actually a 10 plus a 2 if we want to be real technical. And what we need to model is 3 sets of that. So I'm going to draw in 2 more sets of those, forming our little nice little rectangular array. But it works exactly the same way as the other model does. And let me just make sure that you see that this is 3 sets of the 12, right? And just like we found over here, this is going to be 3 times 10 plus 6 times 1, which is 36. Okay. Let's take a look at the expanded algorithm, okay? And the expanded algorithm, the way to do this is to rewrite your numbers as the sum of easier to handle numbers. And so for this first guy here, we're going to rewrite 12 as 10 plus 2, and we're still going to multiply it by 3. And here's the idea. Everything has to be multiplied by everything. So we have 1 term on the bottom and 2 terms on the top, so we're going to have to multiply it by both. We're going to start off with going 3 times 10, which is 30. And then secondly, we'll go 3 times 2, which is 6. And then we get to add those up. So let's see how it looks when we make it a little bit more here. So this would be 30 plus 7 and 20 plus 4. Okay. Now remember, when we are teaching students and it's early in the game, it's really a good thing to work from left to right like we read, and start developing the understanding before we start working from right to left as we typically do our arithmetic like this. Okay, so we're going to start on the left-hand side, and we're going to say 20 times 30 is 600. Then we'll pick up 20 times 7, 140. Then we can pick up here with the 4 4 times 30 is 120. And then finally, 7 times 4 is 28. And we add all that up. 8, 8, 8. Oh, excellent. I didn't realize that. Okay, let's do one more. So 53 would be rewritten as 50 plus 3, and 21 will be rewritten as 20 plus 1. Now, while you're working this, you're going to slowly start eking your way to working from right to left. Okay, so let's do this particular one from right to left. So if that's the case, we'd say 1 times 3 is 3. Then we'd pick up and we would say 1 times 50 is 50. Then we'll pick up here with the 20. 20 times 3 is 60. And then finally, the 20 times the 50 is 1,000. And when we put this together, we've got 3, we've got 11, carry the 1, 1, and 1. Okay, now, before we go any further, we really should explore place value and multiplying by powers of 10. So, and this is really important, and the main idea here is definitely place value. That's really where we're going to get to, is place value. So what happens when we say 23 times 10? Let's be real explicit. Okay, so I'm going to use some base 10 blocks here. Let's look at 23 in base 10 blocks. And let's recall about the base 10 blocks. The base 10 blocks do the powers of 10, right? So this is 10 to the 0 power, which is 1, and then we've got the long, which is 10 to the 1 power, and then we have the flat, which is 10 to the 2nd power, and then we have that cube that I haven't had to draw in a while, and that is 10 to the 3rd power. So notice when we go up, we're actually multiplying by 10. I mean, that's really what's happening here. So you can start to motivate this idea with students by exchanging these or going up to the next value. So when we multiply these guys by 10, this now becomes flats. And the units now become longs. Because we went from one place to the next place. Okay, so 23 times 10, according to this, is going to be 230. 2 flats and 3 longs. Now, what happens when we multiply it by 100? Well, when we multiply it by 100, we're going to go 2. So this is times 10. And then let's do it again and multiply it by 100 so you can visually see it. Because the hard part for us now is breaking down stuff we already understand in the way that we understand it, to present it to present it to students that don't have any clue what we're really necessarily talking about, or that they're weak on the concept, or that they have not seen it before, or whatever. Okay, so if we start off with the long, and if we're multiplying by 100, it means that we're going to skip up 2 sizes. Then the longs are going to turn into blocks. Some really bad blocks going on right here, but that's okay. And then the units are now going to become flats. So multiplying by 100 has you skip up 2 sizes. Or in other words, move 2 places. Okay? All right, let's see here. What's next? Let me take a look. Oh, it's the old expanded algorithm. Okay, let's take a look at the expanded algorithm. And the expanded algorithm is when we take it and we break it into pieces and we use those rules like associative and commutative and rework it down into something a little bit in a different presentation, so to speak. Okay, so let's look at our 23 times 10 here. So 23 times 10, let's break it out here. That is 2 times 10 plus 3. All that crap times 10. Okay, and now we're going to use the distributive property. Okay, and the distributive property says that this is now 2 times 10 times 10 plus 3 times 10. And then we're going to clean this up a little bit because that is now 2 times 10 squared because we learned about our exponents plus 3 times 10. And then if we wanted to finish this up, we could say 200 plus 30 is equal to 230. So that's the way that we can like break it down into all the little tiny pieces and see how that multiplying by 10 moved that place, because we went from 10 to the first power to 10 to the second power, and that was powerful. It went from a number with 1 0 to a number with 2 zeros. Okay, and let's look at this one right here. This can be rewritten as 5 times 10 squared plus 2 times 10 plus 3 times 10 to the 0, right? I think I'll even write that, times 10 to the 0 power. So we've got that guy, and we're going to multiply it all by 7. So we're really thinking about just distributing that 7 in through the parentheses. Remember the distributive property over multiplication. So that gives us 7 times 5 times 10 to the second power plus 7 times 2 times 10 plus 7 times 3 times 10 to the 0, and remember anything to the 0 power is 1. So that's going to leave us with 35 times 10 squared plus 14 times 10 plus 21 times 10, times 10 to the 0, which gives us 3,500 plus 140 plus 21. And frankly, I am terrible about addition that goes across like that, but sorry I didn't do it any different. So I think it's 3661. I believe that is the answer there. How could we do it easier? I'm like, I probably should show that. Where did we go? You would add up the things that are quicker and easier to do. So 3,500 plus 140 would be 3,640 plus 21, and then 40 and 21 is 61, so we get 3,661. Sorry, I tried to skip. I should show every step. So should you. Now that brings us to something called the partial products algorithm, and I'm going to do this with using a concrete model and an array. So let me model this first. Let's get over here to our 23 times 14. So remember when we did the arrays, the idea is to lay out one of the numbers and then build off of that to go up with the other numbers. So here, let me put in our 23. So there's our 23, and then I'm going to build up from the 23, 14. And before we were building from the left side, but right now it makes sense to build off of the smallest unit here. So 1, 2, 3, 4, and along. Okay, so let me make sure that you're following me here. Along this right here was our 23. Going along this right here is our 14. And we need to build out the rest of the array. So let's see here. We're going to just start building it out. Looks like we need this. Looks like we need 1, 2, 3, and we need 1, 2, 3, and now in fact we can keep on drawing these, but we know 10 times 10, or if it's 10 long this way and 10 long that way, then that's a big flat, and so I'm just going to draw those in as flats instead of having to convert it. I'm sorry, I was trying to get to a color so I could show them different color. Okay, and now let's look at what this actually kind of gives us here. Right here we have 2 times 100. And then if you look at this way, this is 20. So this whole section right here is 4 times 20. Or we could say 8 times 10 in that area. Okay, let me make some marks here on where we're talking about. As you can see, there's more than one way that we can definitely work this. Then we've got all these awesome little squares right here, all these awesome units. And here we have 3 by 4, so 3 times 4 of those units. And then finally up here, we still have those 3 units we haven't dealt with, and that would be 3 times 10. So the partial products algorithm gives us all of these numbers that we then need to put together. So we have 2 times 100 equals 200. We've got our 4 times our 20, or our 8 times our 10, which is 80. We have our 3 times our 10, which is 30. And we have our 3 times our 4, which is 12. And then we can just do this math here. We've got a 2, 8, 9, 12 carry. 322 is the answer. Sorry, my heater in my office is too warm. Okay, my office is super cold, and so I have a little heater on, and now I'm like, oh, it's a little too hot. Okay, so let's try this again with another example. And here we have 31 by 23. So I'm going to go across here with my 31. So there's my 30 and my 1. And I'm going to go up from there and do 23. So I'm going to go 3, 2, 1, and 2 longs for my 20. And then we're just going to build them all in just like we did before. So notice across here we don't have to use any little units. We can just fill these in. Oops, I meant to change color and it didn't change. Just fill these in with longs. And then above here, it looks like it's just all going to be flats because we have a long and a long. A long times a long makes a flat. A long times a long makes a flat. So we'll draw in our flats here to finish up our rectangular array. And you can see how this would work really good with the actual physical blocks too. You're literally building it and making it. And then let's see what we've got here. Here, I lost my pen. Okay, there it is. Here we have 6 times 100. Down here at the bottom, remember these are 10 each. So a row of that is 30. So this could be seen as 3 times 30. It could also be seen as 9 times 10. Either way you want to see that. Okay. Then up here in the corner, we've got some more longs here. That's 2 times 10 in the long department. And then down here in the bottom, we have 3 times 1. And so when we get this here, we'll have 600 plus 90 plus 20 plus 3. 3, 11, 7, 13. I think it's cool. Anyway, let's keep on going. Partial products algorithm, the expanded version. Remember, we're trying to get to that normal algorithm where we start on the right-hand side and we carry just the way that we've been doing multiplication a long time. So let's check this out. And remember that we're going to be, when we're introducing this, I'm going to work from left to right with the goal of understanding so we can begin to work right to left in the standard algorithm. All right, so let's check this out in the expanded algorithm. And so the expanded algorithm has us multiplying 10 times 20. So our first is 200, and that is the 10 times the 20. Okay, and now again with the 4 times 20. Oh, sorry, we're working from, y'all ignore what I just said and just watch what I actually do here. Now our next one is going to be 10 times 3, 30. That will be the 10 times the 3. We're taking that 10 and we're multiplying it to both things on top, and then we're done with the 10, and now we can go on to the 4. Now we're going to say 4 times 20. That's going to give us the 80. And then we will finally say 4 times 3. And that gives us the 12. Now you notice this is basically the same thing that we got when we did that concrete array, but a little bit, I mean, it's going to be exactly the same answer, but it looks a little bit different here. And then we'll add down here. 4 is 12, 322. Okay, now this time, so this time I worked definitely from left to right. Let's work from right to left this time. So this one was left to right, and here we're going to go right to left. Okay, so that means that we're going to start off with the 3 times 1. 3 times 1 is 3. Then our next one is going to be 30 times 3, which is 90. So we're going to say 3 times 30. Now we're done with that. We're done with the 3. We're going to pick up the 20. So now it's going to be 20 times 1 is 20. And finally, we'll say 20 times 30 is 600. And that is our 20 times 30. Okay, and then we can just boogie it down here. 3, 11, 7, 13. All right. Okay, we'll keep on going. Let's look at the lattice. The lattice works very similar to how we have done the lattice in other things. Same setup. The differences here is we're multiplying. Let's set up our lattice. So we've got 23 and 14. And each one of the squares has a diagonal. Okay, and each square needs a full number. So let's just do a couple and then you'll see what's going on. So 3 times 1 is 3, and so we're going to go 0, 3. 3 times 4 is 12, so we have the number 12. 1 times 2 is 2, so 0, 2. And finally, 4 times 2 is 8, 0, 8. And now we take what we've already known how to do with the lattice, and we're going to just add down. And so our answer here is 2 plus nothing is 2. 8, 9, 10, 11, 12. This makes this a 12. We carry the 1. 1 plus 2 is 3. So there it is with the lattice. Let's do this other one as well. I don't know why I feel like I have to draw something additional for the lattice multiplication when I didn't feel like I needed to draw anything additional for the addition or subtraction, but I definitely do. So let me do this a little more color coordinated and see if that doesn't help. So I'm setting it up. We got one of the factors on top, the other factor along the side. You could have wrote it on the left-hand side, but again, we're trying to reinforce that doing math from right to left kind of thing. So that's why I wrote it on the left-hand side. I will tell you color coordinating is very, very helpful for students to keep their eye on the prize here. So I'm going to go 2 times 1 is 2, and every box has to have a digit. So if the number is a single digit, you'll have to use a 0. 1 times 3 is 3. 2 times 3 is 6. And 3 times 3 is 9. And then as we did before, we're going to come down. We have this one, we have this one, and then we will have this one. And in fact, we have this one as well. There just doesn't happen to be a number on it. So let's see here. 3 is 3. Okay, y'all. No, I can't go backwards, and somehow I managed to. Yeah, I can't go backwards, and I've advanced this, so darn it. You can add it down and get the rest of the answer. The answer is 713. Okay, let's move on to multiplication and other bases. Okay, so I want to remind you again that multiplication is repeated addition. And I also need to remind you that when we do adding of things and repeated addition in regular multiplication, we never start with 0. We don't count starting with 0. We start with that first counting number, that first number beyond our 0. So I want to remind you that when you're doing this grouping stuff, that you're not going to get 0 is not going to be in the part of your first group. Okay, so let's look at 3 base 5 times 4 base 5 through repeated addition and grouping up 3 groups of 4 digits. Okay, and so, yeah, so let's just brute force this guy out. Okay, so 3 times 4 base 5. I can't find my pen. Okay, so let's have 3 groups. Let's just agree, because it could be 4 groups of 3 digits, but let's just agree that we're going to do 3 groups of 4 digits. And my idea is it's easier, the less number of groups with bigger volume in the group is easier to keep up with. But it doesn't matter. We're going to get the same answer either way. And let's start right here. Remember I said we do not start counting at 0. We start counting with 1, right? So we have to start counting with 1 in these other bases as well. So 1, 2, 3, 4. There's one group of 4. Then we pick up again. 10, 11, 12, 13. There's another group of 4. We pick up again. 14, 20, 21, 22. There's that last group of 4. Okay. And so we have 1 group, 2 groups, 3 groups. We can say 3 base 5 times 4 base 5 is equal to 22 base 5. And let me just show you quickly going that other direction just in case you're not sure about it. What if we do 4 groups of 3? 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. It also lands on 22. Okay? Yay. All right. Measurement model for the win. All right. So, when you start doing a lot of multiplication and stuff like that, it's really, really nice to have a nice table so you're not breaking out the list and having to count backwards and forwards constantly. Although, please, let me tell you, you need to do that. You need to have like an index card that has all these bases on it so you've got it there so you can count, or in your homework write out the list of the digits as far out as you need and get that concrete understanding. It's wonderful for you to learn something in a different base because it's forcing you to kind of see it through your students' eyes. In doing something that you're not familiar with. So it'll open up some ideas for you on the way that you might need to approach students for base 10 as well. Okay, well, I'm going to make this cool little table here. And before I do, I'm going to write down the digits here real quick. 1, 2, 3, 4. We're in base 5. So now we go 10, 11, 12, 13, 14. And then we pick up at 20. 21, 22, 23, 24, and if we went to the next one, it would be 30, right? And keeps on going. Awesome. Let me, in fact, write, I think that'll be all that we need. Okay, so let's get this table worked out. 0 times 0 is 0. In fact, 0 times anything, even in base 4, is 0 because it's the multiplying by 0 situation. All right, and now let's pick up again. So I'm going to go here. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. We agree with all that. And then I'm going to go down the column, so we're doing the same thing. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. Cool. Now let's go inside a little bit. Now we're going to deal with 2 times 2. 2 times 2. So if I'm at 2, times 2 is 4. Perfect. Now let's do the next one. 3 times 2. So we're at 3 times 2 is 6. And 6 is the same thing as 11. So one way you can do this is to go 3 times 2 equals 6. We're at 3, 4, 5, 6. It's one way of looking at it, right? And that's going to be the same volume here. And then what do you think 4 times 2 is? 4 times 2 is 8. So 4, 5, 6, 7, 8. 4 times 2 is 13. Okay. 3 times 3 is 9. So we're at 4, 5, 6, 7, 8, 9. So that is actually 14. 3 times 4 is 12. So 4, 5, 6, 7, 8, 9, 10, 11, 12. That's equal to 22. 3 times 4 is 22. And then finally, 4 times 4 is 16. So here we are at 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oops, we need one more. 31 is 16. And that is going to be that last digit for this. Now, do we need to expand that anymore? No, we don't. This is going to give us everything that we need to do any kind of multiplication. Okay? So let's look at, lost my pen again, there it is. Let's look at this 21 base 5 times 3 base 5. So we've got 21 5 times 3 base 5. And I want to rewrite that. 21 base 5 is 20 plus 1 base 5, right? And 3 is just 3. There's no way we can break that one up. And now we're going to use the advantage of the power of 10 situation that we've already talked about and use our table and get this handled here. So let's just do it in the long expanded way. 3 times 2 is 11, but we have a 0 here. So this is going to be 110 plus 3 times 1 is 3. So our answer is 113 base 5. There's another way we can do it. We can do it kind of like our regular algorithm. 3 times 1 is 3. 3 times 2 was 11 in base 5. Okay, let's see what else we got. Okay, let's use the partial products. Of course, you don't have your little table right there in front of you. You're just going to have to trust me. I have my table here, and I don't want to write another table. This is already at 42 minutes. I'm trying to keep them certainly under an hour, so I don't know if I'll make it, but we'll try. Okay, so let's take a look at this guy. And let's do it in the partial products algorithm. So we're going to go 23 base 5 times 14 base 5. And that partial products algorithm, the first thing we're going to do is we're going to go 3 times 4 in base 5 is 22. Right? Isn't that what we got off of our, yep. 3 times 4 base 5 is 22. That's 3 times 4 in base 5. And then we're going to say 4, and I don't know why I wrote it 3 times 4. Let me be more specific so we're consistent. That would be 4 times 3. I multiplied the 4 times the 3. Now my next iteration is going to be 4 times the 20. And 4 times 20 is 4 times 2 is 13, and add the 0. So this is 4 times 20. And now we're going to pick up with the 10. All right, just like we did before. So this one is going to be 10 times 3 is 30, so that's going to be the 10 times the 3. And then finally, our last one is going to be the 10 times the 20. And that's going to give us 200. Now, let's add them all up here. Looks like we've got a 2. 2, 3, 4, 10, 11, 12, 13, adding up, 2, 3, 4. So 23 base 5 times 14 base 5 is 432 base 5. Let me do this other one here real quick. This one's kind of a long one. So 334 base 5 times 42 base 5. We're going to have lots and lots of these. we're going to start here with the 4 times 2. So we've got 4 times 2. 4 times 2 is 13. And I wrote that backwards again. I should have wrote 2 times 4 for consistency's sake. Sorry about that. 2 times 4. Okay, and then let's do the next one. That's going to be 2 times 30. And 2 times 3 is 11. So 2 times 30 is 110. And the next one is going to be 2 times 300. And that is going to be there. And we're done with that. And we're going to pick up back again with now 40 times 4. 4 times 4 is 31, and we add a 0, so that's going to be 310. The next one will be 40 times 30. 4 times 3 is 22. Yeah, 4 times 3 is 22, so this is going to be 22 with 2 zeros, a 0 from each of the zeros here. And then finally, our last one is going to be 40 times 300. And we've seen 4 times 3 is 22, and so this is going to be 22 with 3 zeros. Add all this down. We got a 3. We have 1, 2, 3. We have 1, 2, 3, 4, 10, 11, 12. Carry this one. I've lost my. Okay, carry this one. 1, 2, 3, 4, 10, 11. One more, 3, base 5. Woo! Woo! That one was good. That one was good. Okay. So let's practice with base 3. And I wanted to just have you make a table fact of addition and then just kind of do a base that we haven't done before. So let's make these tables real quick. So here we're doing addition, right? So 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2, 0 plus 1 is 1, 0 plus 2 is 2. Now 1 plus 1 is 2, 1 plus 2 is 10, right? 1 plus 2 is 10. Next one, 2 and add 1, it's 10. 1 plus 2 is 10. And then finally, 2 plus 2, if we're on 2 and we add 2, we get to 11. So 2 plus 2 is 11. Let's do our multiplication as well. Just make up all these tables here. So 0 times anything is 0. We get all these zeros here. Awesome sauce. Now we say 1 times 1 is 1. 1 times 2 is 2. And 2. What is 2 times 2? So there's one group of 2. There's 2 groups of 2. So 2 times 2 is also 11. That should not surprise you too much, but it is also 11. But notice that the tables are different. Okay. And so let's knock these out real quick. I'm looking for my pen. There we are. 20 base 3 plus 12 base 3. So 20 base 3 plus 12 base 3. 2 plus 0 is 2. 2 plus 1 is 10. So that's 102 base 3. Let's do the multiplication. And I am going to say 23, 12, 3. And we're going to do this kind of like the standard algorithm. I'm not going to do anything crazy because I'm trying to finish this up, and I think I came up with a whole lot of stuff. And I might leave basics for you to work with, so I can end this. Let's see. 2 times 0 is 0. 2 times 2. What's 2 times 2? 2 times 2 is 11. And then we're going to put in our little placeholder here from our standard algorithm. I'm just going to put in a little placeholder here, and then I'm going to say 1 times 0 is 0, 1 times 2 is 2, and then we get to add these up. And we get 0, 1, and there's not a 3. That would be 10. So it's 10, 10 base 3. Let's do this final one. 101, 3, 22, 3. I just want to write tree instead of 3. I really do. Okay. So 2 times 1 is 2. 2 times 0 is 0. 2 times 1 is 2. Putting in our placeholder here. And hit up this next. 2 times 1 is 2. 2 times 0 is 0. 2 times 1 is 2. And it looks like 2, 2, 2, 2 base 3 is the solution. Okay. Next is base 6. I'm going to leave base 6 for you. I think you can see how to come up with the table and how to make everything. I'm going to leave it for you. I guess I could give you I'll give you the answers, and you can work to getting it. The solution for this one here is 343 base 6. And the solution here is 543 base 6. And if you can't find these and you can't figure out how to compute them, let me know, and I'll do a little answer thing. Okay, I appreciate it. Y'all have a good day.